Welcome to Chapter 3, or Unit 1, of Object-Oriented Programming with C#. Welcome to the class, and let's jump right into it. Alright, so this is a really long chapter. Chapter 3 pretty much covers a lot of information, but we're going to try to go over it succinctly, but in great detail. I don't want to gloss over it too quickly because I want you to actually wrap your mind around it to get a better understanding of what we're looking at. So in this chapter, we're going to talk about how to write a simple C# app rather than using visual coding, meaning that we're not going to have a GUI or an output that shows us what's going on. We're actually going to write something that the computer will understand and regurgitate something back to us. We're going to use input data from the keyboard and output data to the screen. We're going to declare and use data of various types. We're going to store data in memory and retrieve it. We're going to use arithmetic operators. We're going to determine the order in which operators are applied. We're going to write decision-making statements and use relational and equality operators. And this is a little bit about what we're going to talk about. Once again, this is not a short chapter, so get some popcorn, Twizzlers. If you drink soda, grab one. We're going to be here for a bit. It's a long chapter, but it's worth it. It's really going to help you in the long run. All right, so let's keep on going. So, what's a console app? Well, a console app is a command prompt app. Really, that's all it is. There's no buttons, text boxes, or anything like that. All it really is an application that does something. And you can use it in XP or Vista. You can use it in pretty much any in any operating system that you use, Windows or Unix-based. They're very powerful, and they can do a lot of things that a normal web application might be too bloated to build and do, and things of that nature. So here's like a little simple console app, and what I'll do is I'm going to take this and throw it into a project. So I'm going to flip it over real quick so we can actually see how this works. Hopefully, I can actually make a console app. I have a community, so let's see what it gives me. Desktop. Oh, I can do it. Whoop. So we're going to name this Hello World. And then I'm going to press OK. Normally I would change this. Users, Frank, source repos. It normally saves it there. Actually, I am going to change that because that's not necessarily where I save my work. Save it to the share. Not the L drive. Let's be real. Let's save this. Oh, no. I got a better idea. Google. We'll go schools. ECPI. OOP. We'll make a folder. Oh, it'll make a folder for me. So, OOP with C#. No, I don't want to name it that. Let's name it Chapter 3. Hello World. Select. There's no folder called Hello World, so let's make one. New folder. Code. Projects is a better word for it. We're going to put this in the projects folder. Select and dump it there. Press OK. I think I named it before it got there, so we should be fine. And all we're going to do is we're going to place this into the program, and it will give us what we're going to ask it to do once it creates itself. Give it a little time. Creating Hello World. You can see it down here. Normally this will tell you everything that is going on. And this is what it should look like. Now, obviously, I didn't call it Welcome 1. So if you go back to the namespace, actually, the namespace is not important. But in this case, I'm using a namespace. It is important, but neither here nor there. So let's talk a little bit about Visual Studio if you don't know it. And I'm going to move my face out of this top right-hand corner because I want to show you, there we go, what my Solution Explorer looks like. So in the middle, you have your code. You have all the DLLs that you're bringing in so that you can actually have references to your code, and you don't have to write those libraries. And then on the right-hand side, we have our Solution Explorer that pretty much gives us an idea of what we have. Right now, the only thing we have in this console application is the app.config, which tells the IDE how to compile the code and run it, and you have your program.class. Now, all we're going to do here, when the console app runs, when the console app runs, the main executes. That is the function that executes. So in this case, what we're going to do is we're just going to add something to the main because we want something to happen when the code is executed. So console.writeLine. What this does is it writes text to your console app, and you'll see that in a sec. Welcome to C# programming is what they have here, so I'm going to add that myself. And then just so I'll get an error, let's close that off, let's save it, and let's run it. Now let's see what happens. Because I'm not telling it to wait, I doubt that it's going to wait and show it to me, but let's see what happens anyway. And this is what I got. I don't think you saw the box, but the box did show up. I'm going to run that again. Maybe it'll, yeah, it popped up and went away. As a matter of fact, let me flip it over to the other screen so you can see it. All right, so I'm going to run it. It's popping up on the other screen. Boom, gone. It actually worked. The problem is that the console app wasn't told to wait. If you don't tell it to wait or wait for a key press or something along those lines, it'll just go right away. Or it'll go away. It'll run that line, and that's that. So let's keep going. A simple C# app displaying a line. You'll insert comments to document your apps. We know this. If you took my JavaScript course, you'll understand that I'm big about comments. The C# compiler ignores comments. So comments are denoted by //. This is a single comment line or single line comment. To do a block, it's / */ yeah, // It's called delimited comments, and it pretty much makes a block of comments. So if I wanted to come over here and I wanted to say write text, that's literally the comment. If I wanted to do multi-line commenting, I would just do that. Now you can see how C# puts those asterisks in there, or not C#, but Visual Studio puts the asterisks in there for you. So either way, let's jump back in. All right. So syntax in a programming language specifies the rules for creating a proper app in that language. Basically, what the syntax is, it's the way the language is written. For those of you who know my phrase is 90% of all errors are syntax related, and 100% of all syntax errors are caused by the programmer, by the developer. We are the ones that incorporate or introduce syntax errors into our languages. And normally these syntax errors can be caught during compile, otherwise known as compiler errors, after compile, so compile time errors, or during the compile, which are called compiler errors. That's all that matters. I apologize. I thought this was going to say like runtime or something else. So syntax errors prevent the code from being compiled. If your code does not compile, that is because you have not written it correctly. In the case of this over here, if I had said console write lowercase line and tried to compile this, I'll get an error. If you see this, there were build errors, and then if I said no because I don't like to run while there's errors, it'll tell me console does not contain the definition of write line. Now obviously write lowercase l line is not a function. I actually have to make this uppercase and it'll go away. As a matter of fact, I can take this a step further, and the great part about Visual Studio is that if I just go back a little bit, it'll give me all the methods and properties that are a part of the console object. Yes, object. So I'm going to put write line back, and I'm going to put back what I had, which was welcome to C# programming, and we're going to continue forward. Alrighty. So, a simple C# app displaying a line and text. A using directive tells the compiler where to look for a predefined class. So, using, they're talking about this. Using. Now, these are predefined classes. I call them DLLs. You can call them whatever you'd like, but normally they're called DLLs or classes. And really what they are, we're asking to import the class into this class. I want you to reference that class because I'm going to call certain things from it. Obviously, if I got rid of system, console would not be accessible. So if I did that, no, you see how console was, the color went away? And the reason why is because the object console or the property console, well, it's really an object. The object console comes from the system namespace, the system class. And so without that class being annotated, it won't work. So predefined classes are organized under namespaces. Named collections or namespaces are named collections of related classes. Collectively, .NET's namespaces are referred to as the .NET Framework. So you've heard .NET Framework 1.0, 2.0, 3.5, 4.6.1, 4.6.2, .NET Core 1.0, 1.1, .NET Core 2.0. That's literally all the predefined namespaces or classes that are inherent to that library, and the library keeps getting larger as time goes on, or more efficient, because that as the refactoring occurs, developers find better ways of making the libraries more efficient. The system namespace contains the predefined console class. So as you saw, I got rid of system and console. It no longer knew what console was. I call console an object because we're using it as an object. So, forgetting a using directive for a namespace that contains a class used in your app typically results in a compilation error. You saw that this error right here popped up when I got rid of using system. Console does not exist in the current context. And when you start getting does not exist in the current context, those types of errors, then you're missing a reference. In most situations, you can right-click it and it'll ask you. Sometimes it knows what's missing. So let's erase this for a second. Using system, it'll go away. It'll give me an error, of course, and then I'll click this little down arrow, and you see where it says the name console does not exist in the current context. Then all of a sudden, magically, it gives me using system. For most libraries in the framework or .NET framework, it knows what's missing. Now, custom objects or classes that we create, it's not going to know inherently, but it knows console. Console's used, I would say, almost all the time in console applications, so it understands where that's supposed to be inherently, intrinsically. So, blank lines and space characters make code easier to read. As you can see, there's blank lines or spaces in between my code. There's a lot of white space so that you can actually see what's going on. And this is called white space. Now, I am a big fan of white space because it makes code readable. The fact that this is tabbed, the console.WriteLine line is tabbed to the right within these brackets lets me know it's inside static. Now, I'll show you something really cool, actually. Let's say I wanted to write an if statement, right? If blah, or blah, blah, blah. I'm not going to put anything in here. Or conditional statement, right? If conditional statement, and then I said, right? Now, watch what happens when I put this curly brace here. Oh, magically, Visual Studio knows white space is so utterly important. And the fact that I put that curly brace back there, it tabbed whatever was inside the if statement to the right. And it does that for every curly brace that you add to Visual Studio. The same thing for HTML. As long as you're not using like Visual Studio like 8 or something very old. Now you saw how I erased that and it didn't go away? It didn't go away because it doesn't work in the reverse. You actually have to fix it. So I would ask, please, to make your code readable, understandable, make it easy to grade, use, whatever, understand that white space is very important. Now, white space is ignored by the compiler, so you can pretty much write your code jumbled up on itself. As long as it's syntactically okay, your code will still run, but it's not readable by humans. So, you choose your battles wisely there. You choose your battles wisely there. White space is very important. So, what are keywords? Keywords are sometimes called reserved words, and we talked about this in JavaScript. For those of you who've not done a JavaScript class, understand that reserved words are reserved for the use by C#. They're words you cannot use as variables or function names or array names. These are words that you just don't want to use as a variable. Void, return, main. Those are reserved words, and normally reserved words are always spelled in lowercase. So protected, private, public, main, namespace, class, static, string. Those are all reserved words. There's more. I don't know them all by heart, but for the most part, you want to stay away from it. Every app consists of at least one class declaration that is defined by the programmer. These are known as user-defined classes. Now, in this case, my class declaration is called program. Now, you can change that to something else. It doesn't have to be called program. Normally, the name of your class is a declaration, so don't, when you create a new class, don't make it two words that are spaced in between, it's not going to run very well. Always make it one word. Now, if you have like, two words that are smashed together like account controller, just don't put a space. Just account controller without the space, and it'll work just fine. So, the class keyword introduces a class declaration and is immediately followed by the class name. So, in this case, you have class program. And that's the way that works. Now, your class name can be anything. You can name it whatever you want. Just like your variable names can be anything, your array names can be anything, which is why we have naming conventions to ensure that we don't have these crazy spellings or really long names that can't be that are spelled incorrectly in some instances, and make it difficult for us to develop adequately without a slew of syntax errors really holding us back. So a class name is an identifier. A series of characters consisting of letters, digits, and underscores. Please try not to use numbers. Letters and underscores are just fine. Numbers, please no. Cannot begin with the digit. That's why I say just don't even use them. And does not contain spaces. And we talked about this. No spaces. The complete list of C# keywords can be found in Figure 3.2. So I don't know if they put that up. Here we go. So here it is. All the keywords that are pretty much taboo to use to name your functions or your variables or your classes or your arrays or anything of that nature. Just don't use these words. Leave them all alone. If you use them, I will warn you, your code will not run. It will say that is a reserved word, that is a contextual keyword. Please do not use that. So we'll try to stay as far away from anything like this as possible. Here's more contextual keywords and reserved words. Okay, so C# is case sensitive. Can I say that again? C# is case sensitive. And you saw that with our function when we try to write console.writeLine. I changed the capital L to lowercase l. It didn't want to work anymore. That's because it's case sensitive. That is, uppercase and lowercase letters are distinct. So A1 and our lowercase a1 and uppercase a1 are different, but both valid identifiers. Now, please don't do this. Like, first of all, no digits. Stay as far away from digits as you possibly can. But number two, try not to make like variables like this because it's very confusing to humans. To the computer is just fine. The computer is going to understand very well what's going on because it can delineate between the two. But we are not very good at that. So if we're going to do A1, do B1. Now, obviously, we're not going to do the number one, but if you must have 1 in the variable, 1 in E or 0 O in E works. There are instances where you'll use the number 1, but it just it's bad practice in my humble opinion. So, by convention, always begin a class name's identifier with a capital letter and start each subsequent word in the identifier with a capital letter. That's their classes. All right. So, program name, the program would have a capital P, and name would have a capital program name, and the N would be capital. Now, if you're doing a variable, it'll be different. It'll be program name. And that's the way that it's been forever, ever, and on. So this is called camel case. Now, C# is case sensitive, not using the proper uppercase and lowercase letters. Well, we just talked about this. Compilation errors. So we'll get another syntax error. By convention, a file that contains a public class, a single public class, should have a name that's identical to the class name. Now, as I said before, your class name is going to be the name of your class on the inside. So the file class name, in this case, program.cs, is my file class name. If you notice, program is also the name of my class inside that file. Normally, whatever you name this class, as a matter of fact, I will prove this to you. New item. Proven again. Add. Proven again. And then I click on it. Proven again. So normally when you right click and make a new class, it will make this proven again class name. No question. I'm guarantee you it will. Okay. So the left brace begins the body of every class declaration. A corresponding right brace must end each class declaration. I know I glossed over this when I was looking at the code. Let's go a little deeper into this. So it's not just for class declarations. It's also for if statements, do while statements, for statements, and the namespace itself, hello world. So what these braces are, these define what's inside the class. They also define what's inside functions. So if I wanted to make a function, static void, I should probably call this in the protected, static void Francis, and then I wanted to write something inside that, I would need to make curly braces. Curly braces are right next to your backslash key on your keyboard in most instances. If you have a laptop, I'm not sure. But for most actual keyboards, it's next to your backslash key. You press shift, and then you can press the curly braces. Curly braces are how you define where your code actually goes. It's the same for JavaScript and most other languages. So, whenever you type an opening left brace in your app, immediately type a closing left brace. Obviously, you saw in C#, when I type an open brace, it automatically types the closing brace. This is just inherent to the code or inherent to the program itself. I'm the IDE, the integrated, or I think it's integrated development environment. Indent the entire body of each class declaration one level. Once again, you saw that Visual Studio does that for you. So, but make it a habit, because when you're not using Visual Studio, it's something that'll make your code a lot easier to read when someone else or yourself goes back to read it. Set a convention for the indent size you prefer. Now, obviously, this is extra information. If you're using Eclipse or something like that, or even NetBeans, I think it automatically does it as well, so there's no worries there. It's a syntax error if braces do not occur in matching pairs. Your braces have to be in matching pairs. So, for instance, if I don't have this last brace here, what do I get? I get curly brace expected, a closing curly brace expected at line 17. If I click this, it'll actually take me to line 17. Now, obviously, there's a curly brace there. So I know these two braces are not the problem, so I'll go up one. These two braces are not the problem. They have an opening and closing brace. Oh, I'm missing one here. Okay, so I'll add a closing brace there, and then bada bing, bada boom, my error goes away, and I can run this. So, having an open and closing brace is very important. If you have one and not the other, you'll run into a lot of issues syntactically. So, and there are situations where you could have an open one and not a closed one, or a closed one and not an open one if you're removing code or adding code and you're just not paying attention. So just take your time, take a deep breath. You got it. It's not as difficult as you think it is. You can do this. Parentheses after an identifier indicate that it is an app building block called a method. Class declarations normally contain one or more methods. Method names usually follow the same case and capitalization conventions used for class names. Capital names for each of the words in the method. For each app, one of the methods in a class must be called main. Otherwise, the app will not execute. Remember what I said at the beginning of the class? The main is what executes when you run your program. Methods are able to perform tasks and return information when they complete their tasks. Keyword void indicates that this method will not return any information after it completes its task. The body of a method declaration begins with a left brace and ends with a corresponding right brace. So, just end quickly here. Here's the main. That is what executes when we fire our code. If we wanted to write a method, main is a method. But let's say we wanted to write another method. You just write it outside of the main in the class. I would say void Francis, and boom, I can write my method right here. As a matter of fact, I can actually write this there. And then instead of doing that, I can say Francis. Now, obviously, it's not going to work because I didn't say it was static. But there, now it works. Static just means that I'm able to call this in other places in the program. Okay. As with class declarations, indent the entire body of each method declaration one level. Once again, Visual Studio did that for us. You can see there's a tabbed indent right here. So keep going. So characters between double quotation marks are strings. White space characters in strings are not ignored by the compiler. The console.writeLine method displays a line of text. The string in parentheses is the argument to the console.writeLine method. So the string, the string here, that is the argument within the console.writeLine method. That is what we're passing to the console.writeLine method to execute. And whatever you pass to console.writeLine, it must be a string, or it will not take it. It'll throw an error. Methods. The method console.writeLine performs its task by displaying, also called outputting, its argument in the console window. A method is typically composed of one or more statements that perform the method's tasks. Most statements end with a semicolon. Most being all statements end with a semicolon. In this case, you'll see this ends with a semicolon. That is a statement, even though I'm calling. That is a statement, even though I'm calling my own method, and this is a statement. And they're both ending with semicolons. In most instances, if not all instances, they'll all end with a semicolon. When the compiler reports a syntax error, the error may not be in the line indicated. Now, we saw that with the curly brace error. It said that one curly brace was not really doing what it was supposed to do, or I'm missing something. I don't know where it is, but I know I'm missing it. So I'm going to put an error in a certain spot in the code, and I hope that you can actually debug to find out where this problem actually exists. So be aware that just because you get an error in a certain place doesn't necessarily mean that's where the error is, or that is the reason for the error. You might have to do a little digging to find out what actually happened and what's wrong. More often than not, you'll know what's wrong more than anybody else, or better than anybody else, because you wrote it. Now, I know this is new and everyone's learning, and I'm not saying that you're going to know it because you're great. I'm just saying you're going to know it because you're the one that wrote it. Now, I'll caveat that by saying the only way you would know what the problem is if you understand the error that you're getting. So, and that's something that I'm going to go into great detail with as we go through this course to give you more information on how to remediate those problems. So, creating the console application. And I did this already, but we'll just go through really quickly. Go to File, New Project. Under Installed Templates, Visual Studio C#, Console Application. If you weren't following what I did, 3.3, this will walk you through how to create a console application project. And it shows you right here, and this is exactly what we did. Visual Studio C# Community actually allows you to create console applications, so no worries there if you want to download it from Microsoft. The IDE now contains the code coloring scheme used by the IDE is called syntax color shading, and it helps you visually differentiate app elements. It also helps you differentiate between what is working and what isn't. As you saw when I removed using system, the console object, the console class, was not accessible. So what happened? The color went away. It wasn't green anymore. It turned black. The reason why? It's because Visual Studio has a built-in syntax color shading feature that allows you to see what's going on and see what's wrong. You'll also see that there's red squigglies under things that aren't operating correctly, and you might even see this, a green squiggly under things that you're not calling. So what that green squiggly actually does is this green squiggly tells you called the variable, but you're not using it. Here, I'll show you, for instance, what that looks like, just in case you run into this. So let's say in the class, I wanted to call a variable, string Frankie. Okay? Guess what? I'm not using string Frankie, and it looks like it's not going to do it. That's annoying. But you see those 3 dots under Frankie? I'm not using it at all. So it's going to tell me, oh, well, I could have said read-only, actually. All right. Give me the red squigglies, or the green squiggly. Give me the green squiggly. It's not doing it. But normally it'll give you the green squiggly when you're not using it. It'll tell you, hey, you're not using this, so you probably should, or get rid of it. It's not doing it right now, though. Bah humbug. Okay, let's keep going. And here you go. The editor window that I've been showing you with all the work, and I showed you where that actual code is going. To rename the app file, click program.cs in the Solution Explorer window to display its properties in the Properties window. I would highly suggest you not do that, because you also have to change the class name and everything else that's related to it. Don't get into a habit of changing your class names. Once it's named, it's named. So I'm not going to change program. I'm going to keep it the same, because I know that later on down the road in real world, it's not in your best interest to change this. Now, of course, Visual Studio has ways of allowing you to change everything that this program.cs is associated with. I just don't take the chance because I've been doing this too long. I just don't take the chance. But if you want to, you can change the file name. Notice, though, that when you change the file name, you also have to change the class name. IntelliSense lists a class's members, which include method names. Now, you saw that when I was playing with the console dot IntelliSense. It dropped down and showed a bunch of programs and I'm not programs, but methods and stuff. Here, I'll show you again. So console dot, and those are all properties and methods. You know it's a property when you see a wrench. You know it's a method when you see a 3D box. And you know it's an action when you see a lightning bolt. So lightning bolt is action. The wrench is a property, and the box is a method. So the method normally has something overloaded in it, and you have to give it something for it to work. The property is what it is. You can change the property if you want. So for instance, I can change the background color of the console app to be, I don't know, blue. Can I make it blue? Console color? Console color. Maybe that's how you do it. Dot. Oh, here we go. Let's do it dark red, and let's run it. See what we get. Oh, I didn't change it. That's not cool. Oh, I know I didn't. Okay, I got you. I got you. Maybe I need to do it here, like that. Save. Start. Nah, it didn't work. I have to pause it, but either way, I'm gonna get that to work eventually. Let's click it over. As you type, IntelliSense lists various items that start, and I just talked about this, so we'll keep going. You can either type the complete member name, double-click the member name in the member list, or press the Tab key to complete the name. While the IntelliSense window is displayed, pressing the Control key makes the window transparent so you can see the code behind the window. So, in that case, I will prove that to you as well. So we'll do a console again, dot, and if I want to see behind it, I did the wrong thing there. I press Tab. Console dot, and then if I want to see behind it, I just press Control key. You can't see me doing that with my fingers, but I'm pressing the Control key right now, and that's the way that works. If you want background color, you can either press Enter or Tab, and it will, or whatever property or method you want inside that inside the drop down in the IntelliSense. And there you go. Here's the IntelliSense. That's the partially typed name, and then it's trying to guesstimate what you want. Normally, it's close to accurate. Now, if you type in something and it doesn't give you IntelliSense, that means one of two things. Either A, you're typing in something that doesn't have a class associated with it, or B, you're typing in something that you haven't said to your IDE, I want that class associated with that. What do I mean by that? So using system brings in a bunch of classes into your program, right? It understands I need to add all that to my IntelliSense, so when you type in something that might be remotely close to what using system has in its library, it'll pull that up for you. However, if it's something that you're coding yourself or programming yourself and it's not inherent, and you're going to run into that later, I guarantee you. It might not show up unless you put it in the using. Then it may. And there you go, right line, as different methods that have the same name. When you type the open parentheses character after a method name, the parameter info window is displayed. This window contains information about the method's parameters. So let's test that for a second. Let's do console.writeLine. And look, there's a tooltip here, but look next to the tooltip, 1 of 19. There are 19 different ways we can fill the overload for WriteLine. We can do it the old-fashioned way and just put a string in there. We can put a Boolean value, true or false. We can put a char value. We can put a char buffer. We can put a decimal value. We can put a double value. We can put a float value. I think you kind of get the point. And you just keep clicking down if you want to see what it can do. And it will tell you all the things it can do. It can even take multiple arguments, either a string format argument or with a params object argument, and that's it gets a little more complicated, but we're not going to go down that road right now. delete that. As a matter of fact, I'm going to put this back where it was. All right. Get rid of my function. Make it nice and simple. Flip back over. All right. So parameter window, right? A parameter info window. And this is what we just talked about this actually. So after you type the app's code, select File, Save All, or you can just Control S. Please get very well acquainted with Control S. You type something, Control S. You're getting up to go to the bathroom, Control S. You're going to look at a video because you're just stressed out about your work, Control S. Control S, Control S, Control S, Control S, Control S. You breathe, Control S. You take a whiff and you think, I need to take a bath, Control S. You go to turn the light on because it got dark. Hey, guess what? Control S. You have a drink right next to you of coffee. What should I do? Control S. Always. Just make it a habit. Control S. You'll make it such a habit that you'll Control S in the browser. Control S. You look at your phone. Oh, dagnammit. Control S. Always Control S. So this goes without saying. To compile the code, you build solution, or you can press F5. F5 is what builds the solution. Well, F5 is what does the start, is what starts the program. You can build a solution by build solution, but that doesn't do anything. It just cleans the code. That's it. And it'll show you errors. Oh, you're getting these errors. It compiles it and shows you the compiler errors. I don't have any compiler errors, so I'll just press start and go and get on with it. So let's keep going. Give me a second. 60 more slides to go. Whoopee. I'm just playing. I live for this. All right, here we go. Pressing the key to continue is not put into the program, so it's not going to stop. I wish it told me how to do that without me looking it up, but it will. I know it will. So let's keep going. As you type code, the IDE responds either by applying syntax, color highlighting, or by generating a syntax error. Remember, a syntax error is error in the code, written error in the code. Not an error logically where the numbers are wrong. No, it means that the code cannot run correctly. A syntax error indicates a violation of Visual C#'s rules. When a syntax error occurs, the IDE underlines the location of the error. Sometimes it tells you there's an exception error as well, and it'll post it in the error list window. And I've showed you that already. One syntax error can make a whole bunch. By solving one syntax error, you could be solving all of them at the same time. So don't get dismayed when you see a bunch of syntax errors hit your window. It could be that one thing made all that happen. And once you fix that one thing, the rest of what you have in your code will run correctly. And we went over this already. So class welcome to has two statements. Unlike WriteLine, the console class write method does not position the screen cursor at the beginning of the next window, and we're going to do this. Now I'm not going to change my class, but I am going to console.write just to test what they're doing. And I'm also going to make it wait because I want you to be able to read it. So let's do this. There we go. All right, so we're just going to say console.readline. Once again, it won't inherently stop if you don't ask it. There we go. Now let's run it. Notice that write still wrote the program to the same line. Write line means write to one line. If I did 2 write lines, it would write 2 different lines. Console.write just means to write it. But you see how it says welcome to C# programming. As a matter of fact, I can make that bigger because that is really, really small. Let's not do the cursor size. Let's do the font, thank you, because we're not necessarily Eagle Vision here. There we go. Welcome to C# programming. A single statement can display multiple lines by using new line characters. Like space characters and tab characters, new line characters are white space characters. The app in figure 3.11 outputs 4 lines of text using new line characters to indicate when to begin each new line. And here, these are the /in is a new line. That's what that means. New line character. New line character. Or break. Or however you want to look at it. So welcome will be on its own line, to will be on its own line, C# will be on its own line, and programming will be on its own line, as you see here. So if I did that, it would look something like this. And then I ran it. There you go. Welcome to C# coding. The /in means new line. The backslash is called an escape character. So if you wanted to put another quotation mark inside of your string, you would use backslash to escape it. So whenever you hear me say escape it, that's what I mean. Put a backslash so you can escape the character. And it's used as the first character in an escape sequence. The escape sequence represents the new line character. So /in is the escape sequence. Figure 312 lists several common escape sequences, and new line, tab, quotes. I just talked about that actually. Let me erase my new line, tab, quotes. I just talked about that. Return. What is that for? No, it's not for comments. This is for backslashing your strings. Backslashing the backslash of your character. So HTTPS would need how many slashes? Well, if that's an escape character, it would need like 4. Console methods, write and write line, also have a capability to display formatted data. So you can break. So this is what I was talking about, the complexity of writing your code. Remember when I showed you the one that, or actually I'll just flip over real fast and let me show you what they're doing there real quick. Dot write line, and then I'm gonna tab down all the way to the one that has multiple values. So here we go. String format. What they did in the beginning of this is they presented you with the string formatting, and then you gave it the data. 0 is the first parameter in the array. 1 is the second parameter in the array. And you said break the 2 in half on different lines. Hence the reason why you got this. When a method requires multiple arguments, the arguments are separated with commas. Place a comma after each, or place a space after each comma in an argument list to make apps more readable. So if I go back, you can see how there's commas here. Comma, comma. To separate the arguments. This is the first argument, second argument, third argument. Splitting a statement in the middle of an identifier or a string is a syntax error. Method write line's first argument is the format string. We talked about that. That may consist of fixed text or format items. In that case, 0 was the first placeholder and 1 was the second placeholder. All you did was then put those two things in the same parameter after that. That was 0 and 1, comma, and that was the 0 and that was the 1. And so on and so forth. You can keep going. You can have 2, 3, all the way to infinity. As long as you're annotating it in this first little format string, it'll print just fine. Applications remember numbers and other data in the computer's memory and access that data through app elements called variables. So now we're getting to the nitty gritty. A variable is a location in the computer's memory where a value can be stored for use later in an app. A variable declaration statement, also called a declaration, specifies the name and type of a variable. A variable's name enables the app to access the value of the variable in memory. The name can be any valid identifier. A variable's type specifies what kind of information is stored at that location in the memory. In this case, all these are variables. Now in JavaScript, you would say var. But in the case of C#, we don't do that. What we do is we give it the data type, and then the name. So int is the data type of integer, and the name is number 1. And in this case, it's displaying a sum of 2 numbers that were given to it through the input from the keyboard. Obviously, it probably says readline somewhere here. Yeah, console.readline means text entered or something along those lines. Variables of type int store integer values. Float, double, and decimal specify real numbers. That's numbers with decimal points. A char represents a single character, whether it's a whatever character that may be. ASCII 2. These types are called simple types. Simple type names are keywords and must appear in all lowercase letters. So, int is always in lowercase letters, float, double, decimal, char, blah, blah, blah. Now, there's an exception to this. String can be uppercase string or lowercase string. There's 2 different classes. Variable declaration statements can be split over several lines, with the variable names separated by commas. Several variables of the same type may be declared in one declaration or in multiple declarations. I think it's because, and it can be separated by a comma. Declare each variable on a separate line. This makes it easier to read. Also, it allows things to be commented out a lot easier. Choose meaningful names. Okay, so I've seen a lot of students run into this problem. I've seen a lot of people in the real world run into this problem. Name your variable as something helpful to remind you of what it's doing. However, sometimes the names of certain things can be exorbitantly long. So please truncate the name. Okay, try to keep it within a reasonable size limit. If you have, like for instance in this case, documentation, that is just way too big of a name. Like doc is enough. Doc, done. If you use this whole entire documentation name, you're going to misspell it at some point in time or another. Or somebody else's. You're just setting yourself up for failure. By convention, variable name identifiers begin with a lowercase letter, and every word, remember I told you about that? That's called lower camel casing, or camel case. So, remember here, Pearson Education down here, right? That would be Pearson, if I can write, and then education. Blah. I'm not gonna write the rest of it because it looks like I'm like a cartoon character writing. But obviously, the first letter of the first word is lowercase. The first letter of the second word is uppercase. The console's readline method waits for the user to type a string of characters at the keyboard and press enter. Readline will not execute until the enter key is pressed. Readline returns the text the user entered into wherever you want to use it. So in this case, let's say for instance, I wanted to, I don't know. Let's say string name equals console.readline, and then I said name plus welcome. And then I said that. And then I ran it. What would happen? So I'm running it. All right. As a matter of fact, I also want to change the color. I said I was going to do this. Oh, go away. All right, cool. Console dot background color. Yeah, equals console dot color. Console color dot dark. I'll make it dark cyan. Let's see if that works. Actually, give me 1 sec. Sorry about that. Okay, so let's run this. And I don't think that background color is going to change any. So notice there's nothing here. It's actually waiting for me to type something. So I'm going to type in my name, Francis Fiske. Oh, it did work! Boss. I wanted the black to change colors. Oh, well. And there it is. Francis Fiske, welcome to C# programming. So what I did here is I filled the name, string name, console.readline, with the console.readline. And then the user typed something in, my name, and then I printed that name using the write line function or method. So to convert classes to int32 method converts this sequence of characters into data type of int. So if you want, and there's a lot of to methods. So to string, to int 16, to int32, to int64, to float, to array, and so on and so forth. A value can be stored in a variable using an assignment operator. You saw me do that with the name. If I flip back over and get rid of that, you saw that here with this line right here. String name equals console.readline. The operator equal is also called a binary operator because it works on two pieces of information, or operands. An assignment statement assigns a value to a variable. Everything to the right of the assignment operator equals is always evaluated before the assignment is performed. Meaning, everything on the right side of this equal sign is executed first. The program is executed from left or from right to the left. Now, why is that? The reason why that is because you can't put whatever somebody types. So in this case, console.readline is asking the user to type something into the console. But you can't put whatever the user types into nothing. You first have to define where it's going to go. Do you just cut up chicken and then just, I don't know, think about it for a second. Can you cook chicken without a pot first? No. Can you sit in a chair before the chair exists first? No. Can you put gifts in a box without a box? No. So you have to define to the program or to the PC, there is something that I want you to fill, a box, a variable, an array, and then I want you to take the data and put it into that box, that array, that variable. In this case, is a string variable. That's why your variables and arrays and things of that nature are always on the left of the assignment operator, and the data that you want to initialize into it, assign to it, is on the right. Everything to the right of the assignment operator equals is always evaluated before the assignment is performed. Place spaces on either side of a binary operator to make the code readable. I put spaces throughout everything. You'll see my code is extremely readable, and if it's not, please call me out. An expression is any portion of a statement that has a value associated with it. The value of the expression number 1 plus number 2 is the sum of the numbers. The value of the expression console.readline is a string of characters typed by the user. We talked about this. Calculations can be performed inside output statements as well. Variable names actually correspond to locations in computer's memory. That is very complicated. You have to get into discrete mathematics to really understand a lot about that. I'm not going to go any deeper than what they're telling you right here because discrete mathematics. That's all I'm going to say. Every variable has a name, a data type, a size, and a value. So in this case, you're going to see some nice. So everything in your RAM has a specific number associated with the memory location. In this case, number 145 was placed at the 45th memory location. Or I'm sorry, the variable number 1 was placed within the 45th memory location number 45 in your RAM. Figure 3.16 shows that 72 has been placed in location number 2. There you go. So, after sum has been calculated, memory appears as shown in the next figure. So, that's the first integer, that's the second integer, that's the sum of the two integers. These all are contained within 3 separate memory locations. Whenever a value is placed in a memory location, the value replaces the previous value in that location and the previous value is lost. Meaning, if you replace the value of a variable, the value of that variable is gone forever. If I went inside the code and replaced the variable of name from Francis Fiske to John Smith, the value of Francis Fiske is gone forever. That's it. When a value is read from the memory location, the process is non-destructive, meaning that it will still be there if you want to see it again, within the session that you're using, of course. What do I mean by that? If I am running my code, so for instance, I ran this. I typed in a name. Please run. There you go. I typed in a name. Gnarls Johnson. Okay. I said enter. It goes away. And I ran it again. It's not going to remember Gnarls Johnson. This is a second session. I closed the first session, or this first session finished itself. And now here's the second session. If I said enter, you notice that Gnarls Johnson's not there because the session was gone and that memory location was freed up again for use by the PC. The arithmetic operators are summarized in 318. The arithmetic operator is a binary operator. And here we go. Obviously, we have addition, subtraction, multiplication, division, and modulus. What's modulus? Remainder of. Take you back to 3rd grade. What's 10 divided by 9? Who cares? Just the remainder of 1. Sometimes that's all you want. Remainder of does have its positives. Integer division yields an integer quotient. Any fractional part in the integer division is simply truncated or discarded and not rounded. So 10 divided by 9 would give you probably like nothing. Would give you 0, if I'm not mistaken, or something like that. 1, actually, it'll give you 1. C# provides the remainder operator, which yields the remainder after division. The remainder operator is most commonly used with integer operands, but can also be used with other things such as floats, doubles, and decimals. Just understand that all three of these use decimal locations. One's just bigger than the other. I think floats have the most decimal locations, doubles have the second most, and then decimals have the least most. Parentheses are used to group terms in C# expressions. We talked about parentheses, but you can also use them to nest or to group algebraic expressions. Remember PEMDAS. Please excuse my dear Aunt Sally. That's important. That is still important with respect to algebraic expressions in programming, because computers do mathematical expressions that way. If an expression contains a nested parentheses, the expression in the innermost of the set parentheses is evaluated first. Math. It's everywhere. Arithmetic operators are evaluated according to the rules of operator precedence. Just said that. PEMDAS. Please excuse my dear Aunt Sally. If you don't remember it, please look it up. Parentheses, exponents, multiplication, division, addition, subtraction. That's the order in which it'll do it. As in algebra, it is acceptable to place unnecessary redundant parentheses in an expression to make the expression clearer, meaning that if you want to make sure the computer executes the expression the way you want it to be executed, then use parentheses. It does not hurt. And here we go. PEMDAS. Modulus is a form of division, so obviously it's going to be done before addition and subtraction. So, order in which the second degree polynomial is evaluated. Remember, multiplication, division, modulus, addition, subtraction. So it's going to do the leftmost multiplication first, which is that actually. It's going to work from left to right mathematically. So it's going to do the 10, then it's going to do the 10 times 5, then it's going to do the 3 times 5, then it's going to add everything. Associativity. If you had a problem with this in math, don't worry. We're not going to do any math. Just know this is the way it works. That's the way it operates. If it's confusing, don't worry. It's really not that hard. Put parentheses around whatever you want to execute first. Done. A condition is an expression that can be either... No. that is Boolean. Let's just get used to using specific, accurate terminology. Boolean. A condition is an expression that is Boolean. Boolean is an expression that can either be true or false. Remember, Boolean. All right? So a condition is an expression that is Boolean. It can either be true or false. Conditions can be formed using equality operators such as equals equals and bang equals and all your greater than equal than or greater than less than operators or your relational operators. Now there's one missing here. Those of you who took my JavaScript class know that there's one more. It is the triple equal sign. That is called strict equality. Now, if anybody knows what that is, you're going to do very well in the class. Strict equality doesn't just measure whether or not the value of a thing equals the value of another thing. That's what that does. This measures whether they don't equal each other. So that is not. So that's what that means. Is not equal. The bang or the exclamation point means is not equal. This means is equal. This means the three equal signs means not only is it equal, but it's the same data type. That's called strict equality. This is the most efficient equality you can use when you're doing strict equal data typing with value expression equality. Confusing the equality operator with the assignment operator can cause a logic error. Just understand that when you're writing if statements, you're using Boolean conditions to write that. So if you're going to do a compare, you always use more than one equal sign. If you're going to do an assignment, you always use one equal sign. And here's another slideshow that might be very important for you. I always get the greater than and less than confused. Just know if it's eating, whatever number is eating, it's greater than that number. Or no, whatever number it's eating is less than that number. Greater than that number. Ignore what I just said. This is greater than, that's less than. Done. Too easy. But as you can see, greater than, less than, greater than or equal to, less than or equal to, equals, does not equal, is not equal to. So 6 if statements to compare two integers entered by a user. And if I get to the if statements, this is the code, but I want to see the if. Here we go. Are the numbers equal? Are the numbers not equal? Is the first number less than the second number? Is the first number greater than the second number? Is the first number greater than or less than or equal to the second number? Now, I'm going to be honest here. There are situations where two or more of these if statements can fire. So let's say I have 1 and 1. 1 and 1. How many of these if statements will fire? That one, and that one. Why? Because 1 is equal to 1. 1 is less than or equal to 1. 1 is also greater than or equal to 1. Let's say this is 0 and 1. How many of these will fire? That one and that one. These will not fire. Or actually, this one will fire. This one will fire. Why? 0 is not equal to 1. 0 is less than or equal to 1. 0 is less than 1. And there you go. You see that? And no, I did not cheat and go ahead of you guys. I'm looking at the code right along with you. If the condition is an if statement, if the condition of an if statement is true, the statement associated with the if statement executes. So, in this case, let me erase all this gobbledygook. If the if statement is true, whatever is inside the if statement is going to fire. However, if the if statement is not true, it will not fire. It'll just go to the next one. An if statement always begins with the keyword if, followed by a condition in the parentheses. An if statement expects one statement in its body, at the very least. Omitting the left and or right parentheses for a condition in an if statement is a syntax error. Parentheses are very important. Very important. So, if this parentheses was gone, right here, this would throw a syntax error. are missing a parentheses. It wouldn't necessarily tell you where that was. It would probably give you like, oh, down here there's a parentheses missing. It's up here. Just look up. If it says something's missing, just keep looking up and up and up and up and up until you find it. That's how most developers do it. Unless there's unit testing and things of that nature. Reversing the operators and as in, so you can't write these in different orders. They have to be written in a specific order. So this is the correct way to do it, right? This is the incorrect way to write them. If you write them incorrectly, you will get logic errors and or syntax errors. Logic errors are worse than syntax errors because logic errors don't necessarily throw an error, but you might get the wrong information back. And I will know. I will know it's a logic error because there's certain data that you can calculate. There's a certain thing that you should get back. Like, for instance, converting specific things like miles and kilometers. Every mile converts to 1.6 kilometers. How do I know that? I was a Marine. I know that. I don't have to think about it. I know it. Years of humps and running. Yes, I know the conversion. Top of my head, 1 to 1.6. So, if you write a calculator and it doesn't convert correctly, I get 1 to 0.6, I know the logic is a logic error. Oh yeah, it compiled just fine. It ran great. But it didn't give me the value I was looking for. So, it's a syntax error if the operators have spaces, so just be careful of that. Don't put spaces in between your operators if you have more than one operator concatenated to another. Indent an if statement's body to make it stand out. Once again, Visual Studio does that for you. You shouldn't have any issues there. Placing a semicolon immediately after the right parentheses of the condition in an if statement is normally a logic error. You don't have to place a semicolon after an if statement. I will say that again. The last curly brace at the end of an if statement, you do not have to place a colon or a semicolon. What do I mean? Let's look. So, if conditional statement, because I'm not. Well, I say if 1 equals 1, right? All right, boom. You saw that, and I say do something. Notice there's no parentheses there. You don't need it. The last curly brace of the if statement does not require a semicolon. Place no more than one statement per line in an app. This format enhances readability. A lengthy statement can be spread over several lines. If a single statement must be split across lines, choose breaking points that make sense, such as after a comma in a comma-separated list. Listen, in most situations, if you wrote too much for a line, well, that's not true. If you do dot notation, you can write too much for one line. But if it's too long for one line, then in most situations it was too long to begin with. So try to break it up. So the precedence of operators introduced in this chapter from top to bottom in decreasing order of precedence is annotated in figure 3.23. Oh, I thought there was a figure. Am I missing something there? Okay, there it is. Okay, there it is. So we'll talk about a good programming practice. Refer to the operator precedence chart to complete when writing expressions containing many operators. So let's just look at it. So we have multiplication, division, modulus, that's remainder of, addition, subtraction. This can also be concatenation if you're using strings. Concatenation means that you're putting two strings together. You're gluing them together. Less than or equal to, greater than or equal to, equals, does not equal, is not equal to, assignment. And like I said, this will become common knowledge the more you use it. And that's it. We made it. We're at the end. Chapter 3, finito. So, with that being said, please understand that if you need anything, just reach out and I'll take care of it. Otherwise, I hope this was very helpful to you. I know I sped through it. If you need a little more of a in-depth analysis on how that all works, don't worry. We'll go over it together. Otherwise, you guys have a good one. Ciao.